And we are Synspective. I'm Asuka Wachi from Japan and the manager of customer engineering. Let me introduce our um, company first. Our mission is to create a new infrastructure that enable the next generation to understand our Earth and achieve a resilient future. We are focused on disaster and security and environment, and a satellite constellation that consistently surveys the Earth from space and analytics for processing the big data obtained from it. Our satellite called StriX. The StriX is the very small satellite. Compared to conventional satellite, the weight ratio is less than 1/10. The cost is less than 1/20th. So it's very small, like the washing machine size. And then we manufacture our small satellite, and we're going to launch the 30 satellite in the future until 2029. So that if we achieve the goal, we can observe the Earth surface or the 2 to 3 hours in the frequency all over our world. Elizabeth already explained about what is SAR sensor, but we can penetrate the cloud, and day and night we can enable 20 hours all weather Earth observation. So, and our business model, we are selling data itself to government or someone who can analyze by themselves, but we're also selling our solution using our data or third parties' data. Then provide our solution to government or commercial partners, the resource energy and civil engineering, of course, mining. So because the SaaS satellite is usually really difficult to understand and for the client, so our solution is really important to know the satellite, what satellite we can do. And the analytics solution, we have main 5 solution here. The one is ground risk and infrastructure analysis that we are calling the land displacement monitoring. And the disaster assessment, the flood damage assessment, and the landslide damage assessment, and the environmental analysis, the forest inventory management, and offshore wind and waves. Okay, let's move on to the mining life cycle, or today's focus. The house Synspective support the entire mining life cycle, the exploration and evaluation and construction and early production, commercial production, the closure or reclamation. The Synspective solution can cover from evaluation, especially evaluation, to a closure reclamation. And there's a lot of risk for the mining, but this is the very major risks for the mining site. The one is tailing dam instability and ground subsidence, the slope failure. We are the monitor before something happen, the routine monitoring that we recommend the use the land displacement monitoring we offer from the using SAR satellite. And of course, on the emergency happen, there we can immediately take your site, acquire the image, then make the solution and provide to you immediately. Then we can offer 2 types of insight for mining from Synspective. The very unique mining monitoring solution using our original InSAR analysis technology. One is millimeter scale of changes. The assessing risk in open pit mine or the stability of the tailing down with millimeter level accuracy. the rotational landslide or dam crops that we can capture precursor to potential ground movement before the event happen. Then the second one is millimeter scale changes, effective observation of large changes in soil amount due to monitoring development such as excavation and filling. So this time I'm going to focus on millimeter scale changes, but if you are interested in meter scale changes, please contact us anytime I can explain it individually. So okay, let's move on. The millimeter scale changes that we are offer the LDM land displacement monitoring. Usually when we want to see the ground movement, they usually use the ground measurement like the level survey or the drones, anything. But it is sometimes coverage is small, and sometimes the data is point or line that can't cover all the surface. But the satellite can cover the surface. We are using two images to make the InSAR. And in the InSAR, we can observe the phase difference, so that we can get more detail of analysis. They're using the advanced algorithm, and we can provide our data through cloud-based data platform. So that is very strong point is millimeter detail and very cost effective for large area. Okay, next one is this is the one example we tried to use our LDM data is for Cadia Mine, Australia. That is very severe. The tailings dam crops happen in 2018. Yeah. Then we tried to 1.5 year analysis. The first from the first the down displacement is very not large down displacement happen, just subtle displacement. But before the tailing dam corruption happened, the 1.5 months, suddenly the displacement rate is the steep. So that we can capture the precursor, the potential or the corruption. A strong point is that I will show that one more example for the strong first point. The ground basement measurement has a very limited coverage. The right bottom is show the coverage of ground-based InSAR. The one-day measurement only are very limited area, but the satellite-based InSAR coverage is very large. You can see all the area of the mining. And lastly, I will show two example for the mining site. We use LDM. Actually, the underground mine in Poland that we tried the 1 year analysis, and then we can see the red and orange color. That it means the displacement happens severely. Monitoring of ground displacement from the surface surface of nearby cities or communities. And the next example is the coking coal mine in India. We tried 1 year also, and then that area, the monitoring of potential displacement caused by underground fire burns. Some orange and red area shows a very severe displacement. So that area is the abandoned mine, so that it is really useful for monitor the abandoned mine too. Okay, thank you so much for your time. If you have any question or interest, let us know. So thank you so much.